Okay, so this is part 2 of 10-7, and we're going to be finishing up our section on probability. So this first example, or I guess this second example here, it says a die is rolled. Find the probability of getting a number less than 5. So I have a die, a 6-sided die, and there are 4 numbers that are less than 5. So probability that a number is less than 5. Another way you could write this is P, and you could say number less than 5. That would be fine too. So there are 4 numbers less than 5. There are a total of 6 numbers, so our answer would be 2/3. Now we're going to look at some specific probabilities. So it says the probability of an event not occurring. So if I wanted to not roll a 3 or not roll a 5. And that's the formula that we're seeing right here. Let's go ahead and look at some examples. It says, find the probability of not getting a number that is a multiple of 3 when you roll a die. Well, how many numbers are a multiple of 3 on a die? There's 2 out of 6, or 1/3. Then the probability of not rolling a multiple of 3 would be 1 minus 1/3 equals 2/3. We can also look at mutually exclusive events. So for example, if we're looking at basketball and we're looking at the Lakers and the Clippers, I can't have both teams win the NBA championship or even the Western championship. They can't both win. Those are mutually exclusive events. So if we're looking at the probability of the Lakers and the probability of the Clippers, those are mutually exclusive events. It's impossible for them to happen at the same time. Something that's not impossible to happen at the same time is if I look at my class and I have students who have, let's say, students who have brown hair. If I want to choose a student who has brown hair who's also a sophomore, it's possible that I could have students who have brown hair and are also a sophomore. So those would be not mutually exclusive events. And we can look at probabilities of these events happening. Now, if A and B are mutually exclusive, so like the probability of the Lakers winning or the probability of the Clippers winning, we would just add those two probabilities together. So let's look at an example. It says, if one card is drawn at random, what is the probability that it is a king or a queen? So the probability of a king or queen, well, that would be the probability of a king plus the probability of a queen, which is 4/52 plus 4/52, which simplifies to 8/52 or 2/13. Now, what if they are not mutually exclusive? So like the example I just said about students with brown hair and students who are sophomores. Then there's a different formula. Now, if I have one student in my class who has brown hair and is also a sophomore, then I'm counting them twice in here, and I'm counting them once in probability of A and probability of B. So what we've got to do is subtract the probability of both happening. So let's look at a specific example. It says, find the probability of pulling a face card, so that would be a jack, queen, or king, or a diamond. So this is going to be the probability of a face card or a diamond. So we want the probability of a diamond plus the probability of a face card minus the probability of a diamond that's also a face card. So let's look at those probabilities. Probability that it's a diamond, well, that's 13/52. The probability that it's a face card, that's 12/52. And there are 3 cards that are diamonds and face cards. The king of diamonds, the queen of diamonds, and the jack of diamonds. So that would be 3/52. And so we'd have 22/52 or 11/26. And we're almost done with this section. Let's go ahead and flip to the next page. And we have independent events, and let's talk about what those actually are. So an independent event is something where the occurrence in each event has no effect on the other. So if I'm rolling a die, if I roll it once and then I roll it a second time, that first roll has no effect on my second roll. Those are independent events. So if we're talking about and probabilities with independent events, we just multiply those probabilities. So it says, suppose you roll a die 2 times. What is the probability that both outcomes are even? So probability 2 even rolls. Okay. So probability that it's even times the probability that it's even would be the probability of 1/2 times 1/2, and that's 1/4. And that is the end of section 7 and the end of chapter 10.